Hello everyone, welcome to my YouTube channel. I am Krishna Gopal. In today's video we are going to talk about another questions from the different topic, what you can expect in your data science or data analysis interview. So in the last video we have discussed about some questions related to the normal distribution, and in today's video we are going to talk about the correlation covariance questions. So what are the questions you can expect from this topic? In today's video we are going to talk about that questions. So let's start the video. Before going to the video, let me show you what are the questions we're going to discuss. So question number 1 is, what is the difference between the covariance and correlation? This question is mostly asked in data science interview. Then there is a famous statement, if correlation coefficient is 0, then the random variables are independent. In some interview they ask you some examples. And question number 3, what are the assumptions of a Pearson correlation? And the question number 4, what is the difference between the Pearson and the spearman correlation? So these 4 questions we're going to cover in today's video. So let us start the video. So we know, as there are the two terms, one is the covariance and one is the correlation. So we will discuss what is the covariance. So covariance is actually measure the direction of two random variables, how their two random variables are moving. Suppose you have two random variable x comma y. So covariance tells how these two random variables are moving with each other, but with what extent they are moving, with what the strength they are moving, it not tell about us. Say if x increase, then y decrease, or y increase. So similarly, if x decrease, then how the y behaving with respect to the x. So general formula of the covariance between two random variable is, we know, if we are talking about here the sample, not the population, just ignore the population sample for understanding now. So general formula is xi minus x bar and yi minus y bar. Here I is equal to 1 to n. So this is the general formula of the covariance. So if this covariance is positive, that means the two variables, the two random variable x and y are moving in the same direction. If this covariance is negative, then that means they are moving in the opposite direction. And if this covariance suppose 0, then they are not related with each other. But if you carefully see this formula of covariance, this covariance formula is depend on the scale. Okay, this is not independent of the scale. Here the scale is what, in which unit you are measuring the random variable x and y. Suppose you want to find how the height and the weight of the students in the same class are varying with each other. So if you measure the height and weight in the meter or in kilogram, then the covariance what you get in this case is not same if you measure the height and weight in the different unit. Okay, that means it is a scale dependent property, covariance, because anyhow if your x is the height and y is your weight and you find the covariance, then generally you get in the units, and again if you measure in different unit, you get the different covariance of the same sample. So the covariance is depend on the scale. So mostly in data science we try to get out of this problem of the scale dependence. So for this we use the method like the standardization or the normalization. So if you perform the normalization on the covariance, then you can remove the scale dependence property. So to perform the normalization, if I divide this covariance with the variance, simple variance of a random variable, that is sigma x and sigma y, I get the rho, that is the correlation coefficient. So this is the story how the correlation come in the picture. So correlation is nothing, it is the normalization of the covariance. So now what the benefit we get when we get the correlation? We not depend on the scale. This is the one of the benefit, because we already performed the normalization. That is the first benefit, that we are now the scale independent. Okay, then second benefit, it measures the relationship between the x and y, like how they are moving, as well as with what the strength they are moving, with what extent they are moving. Because if you see the covariance formula, if you find, then the range of this covariance is minus infinity to infinity. But after performing the normalization, this range, your correlation coefficient is come between -1 to 1. So if your correlation coefficient pointing out to you that it's moving towards 1, that means you have the positive correlation. And if you have the -1, then you have the negative correlation. and if you have the 0, then two variables are not correlated with each other. So the big scale, that minus infinity to infinity, now transform into minus 1 to 1. So the Pearson correlation coefficient measure the direction as well as the strength of the two random variables. So how you can tell the basic difference? What is the difference between the covariance and correlation? We can easily tell. The covariance only tell about how the two random variables are moving with respect to the each other. That means we can only know about the direction, but with what strength they are moving with each other, we not get the information from the covariance. Then the covariance is a scale dependent property. So to get out of this scale dependent property, we perform the normalization and we get the correlation. Now with the help of the correlation, we can tell us the direction as well as we can tell how much with what the strength the two random variables are moving with each other. So these are the basic difference between, and I hope you understand this one. You can explain easily in your interview. But when you discuss the difference between the covariance and correlation, and when you speak these results like -1, when the Pearson correlation coefficient tends to -1, then negative correlation we have. When it tends to +1, then positive correlation we have. But when correlation coefficient is 0, then the two variables are not correlated with each other. So generally the second question what interview mostly ask from here, that if correlation coefficient is 0, that means your correlation coefficient is 0, then random variables are independent. They are giving you one statement and asking you explain this statement with the help of example. So again let's move here and okay. So to explain this statement, you can take a help of an example. Suppose I create one example that if you have the random variable x having the value -2, -1, 0, 1, 2, and all the values have equal probability of 1 by 5. And suppose you create the another value, another random variable, that is y is equal to x square. Now I want to show that the correlation coefficient between the x and the y is 0. And now then I have the x and y two random variables. I have x and y two random variables. I will try to find what is the correlation coefficient row will come, and let's see they are the dependent or the independent. As we know, to check the independent, if the two random variables are independent, then we can easily say the probability of xi yi is equal to probability of xi dot probability of yi. So before going further in this example, it's necessary to create here the marginal density table. So let me create the marginal density table for this. So we have two random variables, and this is we have like okay, so this is x and this is y. Don't confuse here. -2, -1, 0, 1, 2. We have this value, and we have so what the y value can come here? Y value can come, y is a x square, so -2 -1 not come, so directly come 0, 1 and 4. Understand? Y, I think it's clear. Y equal to 0, 1 and 4. So we have to be, this is our probability of yi and this is our probability of xi. Okay, so let's fill this table. This example I'm telling you here to make you understand. You no need to perform this much calculation in your interview to explain this. Just keep some examples in your mind so you can tell them until interview ask you like solve this example in your paper and show us. But I'm just showing you how we can calculate the probability. So let's just fill this table, because if probability of x equal to 0, we have the 1 by 5, rest we not have any value. Then this is also 0, -1, 1, it's become 1 by 5, then 0, and again it become 1 by 5, 0, then -2, 1 by 5, minus 0, again 0, then 1 by 0, and it's again 1 by 5. So here it's come 1 by 5, 2 by 5 and 2 by 5. Here it will come 1 by 5, 1 by 5, 1 by 5, 1 by 5. Okay, so if you take xi is x1, if you take -2, and y1 you take 0. So probability of x1 y1, that is probability of -2 0, what is from your table, -2 is here and 0 is here, it is 0. Now let's calculate the probability of -2 is 1 by 5 and probability of 0 is 1 by 5. Okay, now this 0 is not is equal to 1 by 25. That means these two random variables are not independent. Okay, so this we prove like they are not independent random variables. Now let's try to find the what is the correlation, how we can find the correlation between them. So to find the correlation, we already know the formula covariance of x comma y divided by sigma x and sigma y. So to find the correlation, first I need to find the covariance, and the formula of covariance is expectation of xy minus expectation of x expectation of y. Now from here you can find the expectation of x. So how you can find the expectation of x? As you know, this is the discrete random variable. So minus 2 into 1 by 5 minus 1 into 1 by 5 plus 0 plus 1 by 5 plus 2 by 5. If you add this one, then it will come the 0. So your expectation of x is 0, so no need to calculate expectation of y, so this part becomes 0. Now I am interested to find the expectation of xy. So how we can find the expectation of xy? It's the general formula that x is equal to minus 2 to 2 and y is equal to 0 to 4. So here you find the xy and f of x comma y. Okay, so expectation of xy we can calculate in this way. For the time saving, I just copy this expectation of xy, I just write here. So as you know, this full this one become 0, this one become 0, so just cut it. And this row, anyhow, when the x variable is 0, then this row is fully 0, this is fully 0, and this is fully 0. So these values we cut here. Now we are more interested to get to know what the result we get from the here. So if you see minus 2 comma 1, so minus 2 comma 1 is again 0, so we cut this one again. Minus 2 comma 1 again we cut. Minus 1 comma 1, f of minus 1 comma 1. So here if you do the multiply, it come minus 1 into 1 by 5. So this value come, this one minus 2 comma 4 is value come minus 8. 4 into 2 is minus 8 into 1 by 5, right? Sorry, 2 by 5. Minus 2 comma 4, if you see here, minus 2 comma 4 is 1 by 5. So it is a 1 by 5. Okay, and then if you come here, minus 1 comma 4, again if you see minus 1 comma 4, again it will be the 0. So so we cut this also, we no need this one. Then 1 comma 1 is 1 into f of 1 comma 1 is 1 by 5. Then f of 1 comma 4. So if you see 1 comma 4, again it's 0, again it's 0, we not want this one again. So 2 comma 1 is 2 into f of 2 comma 1, f of 2 comma 1, f of 2 comma 1 again 0, so this also cut. Now 2 comma 4 is 8, 2 into 4 is 8 into f of 4 is 1 by 5. So what the value we get from here? We get the here minus 8 by 5, and we get the 8 by 5 here. Then we get the 1 by 5, and we get the minus 1 by 5. So if you see, this cut from this and this cut from this, so overall the expectation of xy will come 0. So when expectation of xy is 0 and when expectation of xy is 0 implies what? Your covariance is 0, implies what? Your Pearson correlation coefficient is 0. But initially we proved that two random variables are not independent, but they have the correlation coefficient is 0. So if the two random if correlation coefficient is 0, it does not imply the two random variables are the independent. That what we prove in this example. And for just remembering, you can have this example also. If x follow the standard normal distribution 0, 1, and you have another variable that is a x square. Now if you calculate this, that is you can do by in your paper. If you calculate this, then the correlation comes 0, correlation coefficient comes 0, but x and y are not independent. But x and y are not independent. To give you hint, there is a one standard result we have, that if x follow the standard normal distribution 0, 1, and then the x square follow the chi square with 1 degree of freedom. If you use this, then you can easily prove this one. Okay, so these are the two examples for this question, that if correlation coefficient is 0, then the random variables are independent. This statement is false. If the correlation coefficient is 0, then we already show you with two examples that the two random variables are not independent random variables. Moving to the question number 3. The question number 3 is talk about what are the assumption of Pearson correlation coefficient. So what are the assumptions? So Pearson correlation coefficient measure the linear relationship between two random variables. When it measures the linear relationship between two random variables, then I can assume that two random variables should have the linear relationship between them. That is my first assumption between the two random variables, that they should have the linear relationship. Okay, when anyhow it measures the linear relationship, so there should be the absence of outlier, because if the outliers are present, they can skew my result. So I not want any outlier present when I'm measuring the correlation. So absence of outlier, that is your second your assumption. Now third is the correlation coefficient. When we measure the correlation coefficient, the two random variable, the x and y, measured on the continuous scale. That means I can find the correlation between the height and weight, that they are, because they both two random variables are coming from the continuous scale. Okay, and the fourth one, each observation should have the pair of value. That means if you are finding the correlation between the height and weight of a students in a class, that means every student should give you the height and weight value, then only you can find the correlation between the height and weight. If any value become constant, suppose somebody give the weight is 0, okay, somebody put the weight is 0, then your Pearson correlation coefficient is useless. I know the fifth assumption also, that normality, but this have some contradictions, so no need to tell this assumption in the interview. So we should be always on the safe side in the interview, which have no contradiction. We should tell that one in the interview. So this is the third question also we cover. I hope it's clear to you. Okay, so the question number 4 come, what is the difference between the Pearson and the spearman correlation coefficient? See, there are the two types of the correlation coefficient. There are many types of correlation coefficient, but most popularly are the Pearson and the spearman. Now Pearson correlation coefficient measure the linear relationship between two random variables, and the two random variables are coming from the continuous scale. Okay, so then what will happen in the ordinal data types? Suppose you want to find the correlation between the reviews, and the reviews are not coming from the continuous scale, so there you will use the spearman correlation. Now when you find the correlation, when you find the Pearson correlation, you will calculate you have the random variable x, you have the random variable y, you find the covariance, and then you know the procedure to find the correlation. But when you find the spearman, in place of finding the correlation between the x and y, first you give them rank. That means if you have random variable x and random variable of y, first you will find the rank of x and then rank of y, and then you will find the correlation between the rank is the spearman correlation. So spearman correlation mostly work with the monotonic relationship. Okay, with the monotonic relationship. Now what the monotonic relationship? Suppose sin x curve you have. Let's take an example of the sin x. So sin x curve is like this. We remember sin x curve is like this. So it increase, decrease, increase, decrease. So this sin x is the non-monotonic. It's not a monotonic. Monotonic means is what? If x increase, then either y is also increase or y should decrease. Okay, so that is a monotonic relationship. So spearman correlation work with the monotonic relationship. Okay, I hope you understand these all the 4 questions, and with the help of this 4 question we finish this video here. And these are the just 4 questions which are very generally at a normal interview of a data analyst. Even these questions are expected that you give the answer when you are sitting in an interview. I hope you like this video. If you like this video, then please like, share and subscribe to my YouTube channel, and we'll meet you soon in the next video. Up to that, take care, thank you, and bye bye.